Hello ho ho, welcome back to Matplotlib, welcome back to Python. Yeah, and today after looking at many charts and many bars and stuff like that, we are finally heading to pie charts. You probably know the charts or graphs that look like a pie, the round ones. If you don't know what I mean, let's simply create one and I will show you. First of all, like always, we need an array. In this case, we need only one array consisting of a 1, a 3, a 5, and again a 1. And the function, okay, we have to declare it like ax equals np array. And now let's do the function we need is pi. Argument is our array ax. And like always, we need to show our stuff. Let me show you. Here we go. On the right you see our pie chart. What happened here? We had our array and he chose for each part or each element of our array, he chose a part of the chart. And he, for example, he took the 1. 1 is 10% of 1 plus 3 plus 5 plus 1, which is obviously 10. And he made out of 1 out of 10 is 10%. 3 out of 10 is 30%. He uses orange for the next part. Then for the next part he used green, is half of the chart because we are having 5. 5 out of 10 is 50%. And then we got to the red part. 1 out of 10 is 10%. So 10% of the chart is then red. Okay, pretty simple. But that's a little bit tiny for a chart. So what can we do next? For example, we can use labels. Labely equals now again a list of 4 labels. Here we go. Pretty uncreative, but this is just for test courses. So okay, not labely, labels equals labely is pretty much equivalent to the charts and bar, to the matplot bar, I guess. So now we see he starts with 1, 2, 3, 4. Now we see the direction of the pie chart. 1 is the blue one, and if we want to start from the other side of the chart, we can say start angle equals 180. Now let's see what happens. Now we see 1 starts off the other side of the you can see it's kind of mirrored because the blue part is now on the left side instead of the right side. Now what we can also do, we can use explode, and kind of makes us the pie chart will kind of explode. So what we need for that is another array, x2 equals np point array, containing some floats like 1.4, 1.1, 1.1, and 0. Not 1.1, 0.1, and 0.4, sorry. And explode equals x2. Now let's run our code. Here we go. You see it's kind of the 1 because the first one was 0.4, the biggest number. So it has it got most away from the center. So each value of our explode array represents the distance between the center. For example, 1 has the highest value, 0.4, so it has the highest distance from the center. Also pretty simple and pretty easy to do. We can add shadows with shadow, just using a boolean, in this case true. False is the default. Now our pieces have shadows, like they are floating above a white piece of paper. Like always, we can add colors. Let's do that quick because this is kind of similar to the other charts and bars and histograms and stuff like that. Here I created some colors. Now let's see colors equals colors. Let's run it. Here we go. Pretty simple. Because yeah, we made it in our last video. Let's add some legends. Yes, just using MTP point legend. One again. Here we go. Now each color has kind of gotten a little description. We already had that in our last video. Smaller radius can be changed by just using a boolean and using the radius argument, like in this case. Now it got pretty smaller. Let's do it. Can even do it like 0.4. Here we go. And if the also add a title to the legend. Title equals pointless chart. Here we go. Now what is kind of complicated, but auto percent means in the different parts of our pie chart the percentage is shown. For that we are using our percent sign 1.1, now an F for float, again to percent sign. What does that mean? Let's first look at it. And of course, let's change the black one to yellow. And let's add some radius. Yeah, much better. Now the percentage 1.1 we can kind of means 1 percentage after our comma. It's a float. If we want a larger number, like 2 2 elements after the point of our floating point number, we just add a 2, and we can expand it to 3, 4, 5, 6, 7, 8, I don't know. Kind of a little bit similar if you are learning C and you are working with printf. You probably know how to do that. In any other case, just remember what I told you. This number is kind of important for the pie charts. Now last but not least, another great tool of visualizing everything. And for that, let's just delete our auto percentage, because now we are using hatch. Again, square brackets, and in that we are, so if we want to, I don't know how to describe it. If we want a specific background, a kind of hatch visualization, we can add certain symbols as a string, kind of hatching each slice. For example, we can add an O, this one, and even this one should work. Let's add a new line and let's run it. As you see, looks much different in this case. But kind of awesome for our legend, because in this case, even if we have two blue slices, the slices look kind of individual because of our hatch. And there are many ways to alter the hatch. Many references, many patterns. You can Google it, but the possibilities seem to be infinite. And with that in mind, I'm finished for pie charts. And I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. See you in the next part. Bye bye, and have fun with the outtakes. I guess I got some. Then the next one was 3%. He chose orange for that one. Then for 5%, not. You know what? I will do it again. Hello, and welcome back to, oh no, that's too deep. That's better. Hello, and yeah, welcome back to Python, welcome back to Matplotlib, and welcome back to, that was too much, welcome back.